Steps for solving multi-step inequalities. The first you want to do is the distributive property, and that is when there's parentheses in the inequality. The next, you're going to combine like terms, and like terms are on the same side of the equal sign. So you're going to add or subtract the coefficient, or you're going to add or subtract the constants. The next step, you'll get the variables to one side of the inequality. Whatever side you choose, I like to go to the left, so the inequality symbol will be pointing in the direction that I will be shading. So when you move from one side of the inequality sign to the other, you're doing the opposite. So remember that. And once you've gotten to this point, you'll have either a two-step inequality or a one-step inequality. So you'll undo the addition or subtraction, and then you'll deal with the multiplication or division. Now remember, this is the last step. You want to remember that rule, that if you multiply or divide by a negative number, you will need to flip the inequality symbol. So here's an example. We have variables on opposite sides of the inequality. So the first step here is to get the variables to one side. I like working to the left side, so I'm going to subtract the 4x over to the 6x. Again, you have to do the opposite when you're moving from one side to the other. So we're left with 2x plus 15 is greater than or equal to 125. Now it's a two-step inequality. You're going to undo the addition or subtraction. In this case, we're subtracting 15. And then we're going to deal with what's attached. Now this is multiplication. The inverse operation would be division. So you're going to divide both sides by 2, and you're thinking of that rule. Are you dividing by a negative? No, it's positive, so you don't need to flip the inequality. So your solution here would be x is greater than or equal to 55. So that means that x is either 55 or above. So we're going to graph our solution, and when it's greater than or equal to, we're going to have a closed circle, and we're going to shade to the right. Pause and try. So again, I'm getting the x over to the left-hand side. I subtracted 2x over. I'm left with 3x minus 4 is greater than 8. I'm going to add the 4 over. I get 3x is greater than 12. And at this step, I'm making that decision with that rule. I'm dividing through by 3. It's not negative, therefore I do not need to flip the inequality symbol. I get my solution, x is greater than 4. So it's going to be an open circle at 4, and we're shading to the right. Now here's a multi-step equation that has parentheses in it. So the first thing we're going to need to do is the distributive property. Always double check your arithmetic with the distributive property. You're multiplying a negative 2 to a positive 4, we get a negative 8. Negative 2 to a minus 2x is going to change to a positive 2x. And then we have that negative 4 is being distributed, so we get a negative 4x, and a negative times a positive, we get a negative 20. And it's going to be less than or equal to a negative 24. Now we're going to combine like terms. And notice here when we combine like terms, positive 4x minus 4x cancels out. So we lose the variable. So when we have a scenario where we lose the variable, we need to look at what's left. I have a negative 28 is less than or equal to a negative 24. If it's a true statement, and in this case it is a true statement, negative 28 is less than a negative 24. If it's a true statement, then that means that my variable can be any solution. So my answer here would be all real numbers, and to indicate it on a number line, I would shade the entire number line in. That means all real numbers. This next example, again, we're going to do the distributive property first. I distribute that 3. I end up with 3 minus 6x is greater than 8 minus 6x. Now when I add the 6x over, I see that my variables go away. So now the variable is lost. There's no longer a variable. So now I need to look at what we have, and we have 3 is greater than 8. Well, 3 isn't greater than 8. So this is a false statement, and when it's a false statement, what that means is there's no solution, or our solution's an empty set. And to indicate that solution, we would have a blank number line because there's no solution. Pause and try. So we do the distributive property here. We get 3x plus 3 minus 3x minus 9 is less than or equal to a negative 5. When I combine like terms, I see that the variable goes away, and I'm left with a negative 6 is less than or equal to a negative 5. Negative 6 is less than negative 5, so therefore it meets the condition, and our solution here would be all real numbers, and we would shade the entire number line. Pause and try. So we do the distributive property. We combine like terms, and we see when we get the variables to the same side of the inequality, the variable is lost, and now we're left with 1 is less than or equal to a negative 12. Well, this is a false statement, therefore there would be no solution. So now we're going to do compound inequalities, and compound inequalities are connected by the word and or. So it means we have two or more inequalities. The first one we're going to discuss is the and. Now with the and compound inequality, we don't always see the word and, but what it looks like is a variable between two inequality symbols. And when it's between two inequality symbols, the inequality symbols will be pointing in the same direction. And what this means is my value for the variable will be between a negative 2 to 5, including 5 because I have the equal to symbol there also. So when we look at this and we want to graph it, it goes on the number line like the inequalities. So I'm first going to plot the point for the less than a negative 3, which is going to be an open circle, and at the less than or equal to 5, I'm going to have a closed circle at 5, and we're going to shade everything in between. That will represent the solution for an and compound inequality. This means that my variable is every number between a negative 3 and 5, not including negative 3, but including 5. An or compound inequality are two separate inequalities. Two separate inequalities, and you will graph the two inequalities on the same number line. So when you have a graph, you graph the first inequality, which x is less than a negative 1, and we have an open circle, and it gets shaded to the left. And then that or x is greater than or equal to 2, and I'm going to graph that on the same number line. I'm going to have a closed circle at 2, and it's going to get shaded to the right. So you see here with an or compound inequality, the directions of the graph go in opposite directions. This would be an or compound inequality. So now we're going to be doing an example here of finding the solution to a compound inequality. When we have a compound inequality and it's in between two inequality symbols, it's an and compound inequality. And we want to isolate the variable in the middle of the two inequality symbols. And to do that, we do the same thing we would do if it was an inequality or an equation. We're going to undo whatever is with the variable. So in this case, I have an x plus 2, and I want to isolate the x in the middle of the inequalities. So that means I need to get rid of the plus 2. And to get rid of it, I have to undo it, which is subtract. So when I want to move or isolate the variable, we're undoing it. I'm subtracting 2. But you have to make sure that when you do the subtraction or whatever it is to isolate the variable in the middle, you do it to both ends of the inequality. You have to balance it out. So you need to make sure that you do it to both ends. So in this case, I end up with a solution of a negative 4 is less than x, which is less than or equal to 2. So this is my solution for this compound inequality, and now I would graph it on the number line. An open circle at negative 4, a closed circle at 3, and we shade in between. Now this is another example of a compound inequality and. I have an expression in the middle, and it's a two-step expression in order to get the variable isolated in the middle. So you're always going to work the way you work an equation or an inequality. The first movement here is to add the 8. And remember, you must add the 8 to both ends of the inequality. So we're adding 8 to both ends, and we're left with 6 is less than or equal to 3x, which is less than or equal to 8. Now x is still not by itself because I have 3 attached to it. And remember, when something's attached, it's multiplication, and the opposite or the inverse operation would be division. So I have to divide here by 3 to isolate the variable in the middle here, and whatever I do, I have to do to both ends of the inequality. So I end up with my solution here is 2 is less than or equal to x, which is less than or equal to 6. So now I will graph my solution. I'm going to have a closed circle at 2, closed circle at 6, and I'm going to shade in between. Pause and try. So this is a two-step. The first thing I'm going to do is subtract 3 from both ends, and again I'm going to be left with 0 is less than or equal to 2x, which is less than or equal to 4. X is still not isolated in the middle. I have to divide through by 2, and that means I have to divide both ends by 2. Be careful here, because 0 divided by 2 is 0. So I end up with 0 is less than or equal to x, which is less than or equal to 2. So when I graph this, I'm going to end up with a closed circle at 0, a closed circle at 2, and we're going to shade in between. So now we're going to do an OR compound inequality. And when we have an OR compound inequality, we're going to end up doing two separate inequalities and then graphing them on the same number line. The OR compound inequality will be separated by the word OR. So I'm going to first solve the first inequality here, and it's a two-step inequality. 3x plus 8 is greater than 17. The first move I'm going to do is subtract 8 from both ends. I end up with 3x is greater than 9, and now I need to divide through by 3 to isolate the variable. So the first part of the solution is x is going to be greater than 3. I'm going to find the solution for the second inequality. It's a two-step. I'm going to subtract 5 from both sides. I get 2x is less than or equal to 2. And now I need to divide through by 2. And I get x is less than or equal to 1. So now I have my two parts of the solution. It's an OR compound inequality. I'm going to graph it on the same number line. And I'm going to first graph my x is greater than 3. It's going to be an open circle, and we're going to be shading to the right. And that x is less than or equal to 1 means I'm going to have a closed circle, and I'm going to be shaded to the right or the left. So be careful when you're doing this that if the compound inequalities are not written the way the number line is written, that you graph it correctly. Pause and try. So again, I'm doing the compound inequality. I'm solving each separately. I subtract 8 from both ends. I get 3x is less than a negative 6. I divide through by 3, and I get one solution is x is less than a negative 2. The second one is a one-step. I add 1 to both sides, and I get x is greater than 6. So now I have my solution for the compound inequality OR, and I'm going to graph it on the number line. I have an open circle at negative 2. It gets shaded to the left. I have an open circle at 6, and it gets shaded to the right.